I want to look now at three important exponent laws. And the first one involves multiplying powers. And here's an example. If I had 3 to the exponent 2 multiplied by 3 to the exponent 4, and what I'm going to want to do here is write my answer in terms of a power. Well, I know that 3 squared means 3 times 3, and I know that 3 to the 4th exponent means another multiplication of 4 3's. And if I write my question out that way, this times this, I can see that the net result is that I have 6 factors of 3. In other words, 3 to the 6th exponent. And so 3 squared, which is 9, times 3 to the 4th, which is 81, is equal to the answer to 3 to the 6th. And you could type that in your calculator and see that in fact it does equal 729. So you might wonder, well, why would I want to leave my answer as a power instead of a number? Why would I want to do this? Well, remember, exponents are used often for very large and very small numbers. So for example, if I had 10 to the 600 exponent, this is a huge number. Okay, your calculator probably can't even handle it. And I wanted to multiply that by 10 to the 500. Can I come up with an answer here? Well, I'm going to have 600 multiplications of 10 times 500 multiplications of 10, which should be 1100 multiplications of 10. All right, and so instead of working my answer out as an actual number, I can leave it as a power. And so this rule of exponents works for multiplying powers, but it only works if the base is the same as it was here. 10 to the something times 10 to the something is 10 to the, add the exponents to get the answer on the exponent. Same thing here. If you have different bases, then you have to do the question by working up the number the old-fashioned way. So to generalize our rule, if we have a base to an exponent m times the same base a to the exponent n, I can get my answer by adding the exponents. Alright, let's look at dividing powers with the same base. If I take 4 to the exponent 5 divided by 4 to the exponent 2, again, let's try to reason this out. We know that 4 to the 5th is 5 multiplications of 4, and 4 squared is 4 times 4. And so I could reduce this basically expanded fraction by canceling common factors. 4 divided by 4 would be 1, 4 divided by 4 would be 1, and I could see that I would be left over with 3 factors of 4. And so you can see that the net result is that from my original question that had a common base of 4, I was able to get my answer, or I can get my answer in a faster way simply by subtracting these exponents, 4 to the 3rd. And so if I had negative 4 to the 100 divided by, now to use this rule, remember the base has to be the same, so let me pick a common base, divided by negative 4 to the 2nd, my base is negative 4, so that's in brackets. Remember, having the brackets and not having the brackets is important because it can affect the answer. And since I'm dividing powers with the same base, I can see from my example above, I can get my result by subtracting those two exponents to be 98. So my rule here, my generalization, is that a base of a to the exponent m divided by a base of a to the exponent n is equal to a base of a, and to get the exponent I subtract the exponents. This is true as long as the base isn't 0. And a third rule of exponents for now. Let's suppose I had 2 to the exponent 3, and I wanted to take all of that and raise it to the exponent 4. Alright? Can we figure out what that answer would be as a power, not as an actual number? Alright, well, the exponent 4 on the outside means to take my base, which is 2 to the 3rd, and multiply 2 to the 3rd by itself 4 times. Right? And so I'll notice that I have 2 times 2 times 2 here, times 2 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 times 2. In other words, I've multiplied 2 12 times. Alright, and if you say, can I go now from here directly to here in a faster, shorter way, you'll notice that, yeah, if I just multiply those two exponents, I'm going to get my answer 2 to the 12th. So my rule here is that if I have a base to an exponent m, and that's all raised to an exponent n, I can get my simplified answer by multiplying these two exponents, a to the exponent m times n.